Hello guys and gals, my name is Dr. Pettis at Dr. P Learning. At this channel, I teach project-based and hands-on CTE and STEM content. We focus on engineering-based projects, CAD, and 3D printing. If that is of interest to you, you're at the right place. Please like and subscribe to the channel so you can be notified when a new lesson is published. Okay, so let's get into today's lesson. In today's video lesson, I'm going to teach about how to use an ultrasonic sensor to detect movement, and we know that that's what the sensors do, but then change the frequency of a sound on a speaker when motion is detected at various lengths. The words that we're going to be reviewing today, and then also some new words that we'll be learning about. Already talked about the ultrasonic sensor. We learned about the trigger and the echo last week. The trigger sends the signal. The echo receives the signal. The speaker we're going to refer to as the buzzer. And that's the buzzer that we'll be using. And we're also going to learn about different pitches. And those different pitches are called frequencies. So a high frequency is something like somebody that maybe somebody that yells, or maybe that somebody sings. And then a low frequency is, it sounds like this. It's a deeper frequency. Okay. All right. So now that we have some general ideas about the vocabulary, again, the buzzer is the speaker. I showed you that just a minute ago. And then the two different types of frequency. One is a high frequency and one is a low. Some of the components we're going to be using, just like always, we'll use your Arduino, or in my case, an Iligu, a breadboard, the ultrasonic sensor, a buzzer, and then some various wires and jumpers. There's no LEDs today. Our next assignment will have an LED, and that's going to be a pretty cool assignment because we're going to pair that with the buzzer. So we have some various jumpers as we're getting set up here. I want to show you how I set up the board before I kind of move on. I set it up just a little bit differently today. As you can see, and if you remember, this entire row here, if you see my finger pointing, is all positive. Okay, that's power. So I went ahead and put a jumper from there to row 18. And then what I did was I took this pin and I put a jumper here to row 18 on the other side. That other side is connected to VCC, which is the power. Okay, that's how this receives its power. On the other, this is the negative. I put the negative in line here. I put a jumper to pin 15. I jumped pin 15 to pin 15 over here. And wouldn't you know it, pin 15 is lined up with the ground on the, you can see G and D. G and D right here on the ultrasonic sensor. So I'm going to set it up just a little bit different today. This is, really want to make the board as clean as possible. So this is why I chose to do it this way. All right, moving on. So remember, what are we measuring in or with the ultrasonic sensor? If you remember, we are measuring sound. That's right, we're measuring sound. Just really a quick review. There's the VCC, which is the power. The trigger sends the signal. The echo receives the signal. And the ground is, well, it's the ground. Okay, so just a quick review there. So 2 questions that we want to make sure that we're going to answer as we're using the sensor is what's going to happen to the, and that says LED, but that should actually be speaker when you put your hand in front of the sensor about 75 centimeters away, and then what is going to happen to the LED when you put your hand in front of the sensor about 10 centimeters away. I did not update this slide completely. I'm so sorry. There's some misinformation on here, but we'll go with these centimeters there. First thing we're going to do is we're going to look at the mechanical sketch. Basically, it's the technical drawing. So next slide. I'm going to blow this up so you can actually see this pretty well. You see on the board here, we're going to run a wire from the 5-volt to the positive side. So we're going to go ahead and do that now. Actually, we'll do it in just a minute after I show you. And then we'll run the ground from here to the negative side. Right, negative side right here. Trigger in this sketch is going to be pin 6. Echo is going to be pin 7. You see that the ground is here. The speaker will be plugged in. The negative side of the speaker will be plugged in here. The positive side will be on the other side here. And this blue wire represents our speaker wire that goes to pin 12. Okay, so I'm going to go ahead and show you in real time. All right, so 5 volts plugged in. The other side is going to go to plus. Okay. Oh, you can't actually need them. All right. Okay. 5 volts plus ground. This is the closest ground, so we'll use this ground here, and we'll plug this into negative there. Here to you. Yeah, there you are. Keep plugging you the best. All right. It looks like we have echo and echo going to 7. Here, and echo is orange. So I'm gonna plug into pin 7 to echo. Trigger is pin 6. And that's going to green. Echo 7, trigger, okay, yep. All right, and then we have our speaker going to pin 12. What I'm going to do first is I'm first going to, and I like to leave this sticker on the top of my, and shows me, it has me marked there where the positive pin is. So this is my positive pin. As you can see, just like the LED, the positive pin is slightly longer than the negative pin. So I'm going to go ahead and plug my negative into the ground first. Okay, you got to make sure that it's in this row 15. So, and then while you're doing that, you need to make sure you can see where your positive is going plugged into. So it looks like mine's going to go plugged into row 12 on the board. So how convenient that row 12 and pin 12. Boom. Just like that. All right. Now that we have our board set up, we can move on to the next piece. So as we just showed you, we set the board up. Now I'm going to show you the code. So I'm actually going to make this a bit bigger. So in this case, a buzzer is going to sound when the ultrasonic sensor detects an object and breaks some threshold. So in this threshold, our threshold will be 75 centimeters. Okay. So as we start, we're going to define our trigger. That's pin 7. Our echo is pin orange. Okay. 7 green, 6 orange. Speaker is 12 at blue. Okay. Our pin setup. Remember, our trigger sends out a signal. Our echo receives a signal, and then the speaker, because we're listening to it, because this is something we can hear, that is also considered an output. Excuse me. So now we're going to start our loop. We're going to be measuring duration, so how long it takes for the signal to come back. And then by that, we'll be able to measure distance. So for the HCSRO4 or the ultrasonic sensor, we're going to say that we want the trigger in a high state, so we want it to send that signal. We're going to delay for 10 microseconds, and then we're going to turn off the trigger. While we're doing that, what happens is the echo turns on, okay, and then the timer turns on, and then the timer ends on low, and then but by doing that, we're and this I'm sorry, this is the code here for distance in centimeters. So as we send that signal, the signal comes back. However long it takes, we're going to divide that by 2. We're going to divide all that by 29.1, and this will give us distance in centimeters. So this is the equation for getting our distance in centimeters. So distance equals the duration, how long it takes for the signal to go out and come back, divided by 2, and we can divide that by 29.1. Okay. So then the speaker loop. Okay, so what you're going to want to change on this one are the map and the tone. So you can change tones here, but the map numbers are all defined right here. So the numbers that we're mapping are 20 and 50. Okay, so these are the distances: 20 centimeters, 50. 20 centimeters, 50 centimeters. At 20 centimeters, and really this should be more like 10 centimeters, you want the pitch to be 2000. So you want that really high pitch. At 50 centimeters, so further away, you want the pitch to be at a lower range. Okay? So this is going to define the range of pitches based on your distance. Okay? And then you have your tones. You always want to delay for proper or good sensor function. Okay? So the bottom part of the code, if the distance is less than 75 centimeters, then the speaker is going to be in a high state. Otherwise, or else, the speaker is going to be in a low state. So if it's greater than 75 centimeters, the speaker will be off. And then that's the end of our code. Pretty simple, pretty simple, pretty simple. Okay. Let's go ahead and go on to that. Okay, now that we have the code, we understand the code, I'm going to go ahead, as I always like to do, and upload the code. I've already done that to this particular board, but I'm going to go ahead and plug it in so we have power. I don't have this one on all the time because it does get annoying when you hear that beeping noise. I'm going to go ahead and plug it in. Okay, so there's nothing in front of this sensor right now. Put my hand in front, so I'm about greater than 75 centimeters away, at least I know. So I'm going to start moving my hand closer. Okay, you hear the tone. As I get closer, you hear that frequency change just a little bit there. And this is where you can go into your code, and I move my hand out of the way and he stops. You can go in there and you can really change these numbers right here. Like you can put 10, 75, and this really will define the range of pitches based on your distance. Okay, so really play with these numbers, change them. Remember these first two, distance, the closest distance, the furthest distance away. This number and this number will match one another. So this is your distance, this is your pitch. This number here, this is your distance, this is your pitch. Okay? All right. I want to thank you for visiting Dr. P Learning. Please remember to like and subscribe to the channel. We will see you on the next lesson.